I'm gonna be honest, I'm a bit nervous here, and going after Ryan, my presentation is probably a bit more sterile and corporate, but that's what I know. So we have Building a Galactic War, and for the people who have missed it, it's from this tiny game, we call it Helldivers 2, that I want to say released recently. But given that the first game dev meetup was 2 days before launch, and that was a year ago, I figured this is probably about a year ago. And the fact that we celebrate a 1-year anniversary on Friday confirms it. But anyway, Building a Galactic War. And for all the designers here, aspiring designers and game designers who wondered, how do you design a metagame for 100,000 people? How do you make players feel like they have agency? How do you explain the intricacies of the mechanics to all the players? How do you make players engage with it? Or anything else game related? Nope, we're not doing that today. That's not what I know. Instead, this is me. I'm Mona. I am a programmer at Arrowhead Game Studios. Specifically, I'm a back-end developer at Arrowhead Game Studios. And I think a lot of games today have a live service aspect. There are a lot of back-end development, but I still think it's not well known. So I don't think a lot of you actually know what I'm gonna talk about. But I'm gonna try and make it work anyway. Nope, sorry, this thing keeps falling off. I've been at Arrowhead for 5 years. I've only ever worked for Helldivers 2. And when I started, we were already 3 years into development. Previously, I did not do games. I've been coding for 25 years, which is a bit weird because I'm only 35 years old, but I made it work. But I've been a professional web developer for 12 years. And I did transport, did ferry booking, I worked in the financial sector, and I worked with banks. I am not a game developer. That is not what I do. And I want to be very clear about that. However, I learned programming because I wanted to make games, and I usually describe myself as a game developer hobbyist. That's the term I use. I'm self-taught in, well, basically all the fucking languages. And said, I've been doing this as a hobby for, yeah, give or take 25 years. Mostly Unity. Kind of like it because C# is my go-to language, which is also what we use at Arrowhead for the backend. And I'm gonna go through the war so you can know what I'm actually talking about. If you've played Helldivers 2, you know that if you go to the holo map, this is how you do map selection. This is where you choose how to play. It was a thing in Helldivers 1. Superficially, they are the same. Mechanically, they play nothing alike. Most importantly, the one in Helldivers 1 lasted maybe a few months. The one we have has been going for a year so far, and we have no signs of it slowing down. The war was already there when I started. The version 1 was implemented. We are currently on maybe the 3rd or the 4th iteration. We've been going through a lot. It's changed radically, and still does kind of the same. It's still a shared play space for all the players. Every player who starts up the game will see the same state. And the state of the war decides where you can play. And it changes depending on what players do. So collective action here is what moves the game forward. We have a lot of people on Reddit and a lot of people on Discord who's trying to coordinate, and that is needed. We also have a lot of division between the groups, which generally turns out bad, because as I said, there is one war for the whole world. I would not call Helldivers a narrative game. We are not The Last of Us. But the narrative we have is generally displayed here through the war. And very important, it runs live and it's very much real time. So there are some mechanical problems to solve. As I said, we run it live. We can't take it down because if you're a player, you can't play. which is game always playable. We can't be in a state where there's nothing to play. People need to be able to start up the game. Whatever we do, you can enjoy it. If you don't care about the galactic war, you should still be able to play the game. If you were with us at launch, we had 750,000 players at the same time. So it needs to scale well, can't go down. We also have a very dynamic load, or a variable load. We can have 30,000 players, we can have 250,000 players, and they can fluctuate very quickly. Did any of you see the Game Awards? Did you notice that we had an ad spot in it? Did you also notice that our player count multiplied over the time span of about half an hour? So we have to be able to handle that too. And then we have resilience. We can have outages, like mistakes will happen. The war will go down. We will have bad data. That is facts of life. We need to be able to go through it. We need to be able to work anyway and recover. And this is for the developers, but we need Ether replication. I need to run this on my local machine. So I run War on this laptop actually. It works. And we have a live environment. We also have 4, 5 dev environments for the studio. And they need to be as close as live as possible. So we need to be able to replicate this. And this is a new issue for me as a web developer, because usually we control the backend and the client. In this case, the client is a game, and we patch that maybe once a month. So if we want to change something in the backend, the game needs to work with it, or we can't make it go live. We also have some design constraints. We have these things called game designers at Arrowhead. They are opinionated. They usually make things a lot harder. Some things are not constraints though per se. For example, we at Arrowhead make multiplayer games, but all of it is peer-to-peer. That's all we've done. All our games are peer-to-peer. And from my point of view, it means I don't need to care about servers for the games, at least. Only the meta game. Because there's been a lot of great games launched lately that had less than a stellar launch due to missing servers. We had a less than stellar launch, but it wasn't because this. As I said, we have a single war, because a lot of the issues we had could have been solved if we split it out to multiple regions. But the game design said no, one war globally. So we had to act on that. It needs to be a perpetual war. It's quite easy to run a war, make it stop, clean it up, run again. No, it's still the same war we started technically like 2 weeks before launch. And we have a lot of players pulling data from us. They need to read the state, and they need to affect the war, so they need to report back. That's a lot of data going back and forth. And we need to do that with what I call negative gameplay implications. That basically just means slow response times or timeouts where you don't get data. You need a war. If you come into Helldivers and you don't have a war running, your holotable is empty, can't play. It runs in real time. We need to act on your data in real time. We need to progress the war in real time. And we need to act on your actual data. The war is live. If you ever wonder, like, do we fake it? Is it fake? No, we act on you. If players don't play on a planet, nothing happens. If everyone focuses on one planet, yeah, you're gonna take it. There is no fake involved. So now we are at, I would call it a more technical aspect here. Because this is how we built it on a very high level. This is the game running. As game developers, you think this is like the thing you build. From my point of view, this is the one thing I don't control. This is the one thing running at your home. Can't control it. Now we're entering our service. This is the public web API. For those who know, this is a nice Kubernetes service. For those who don't know, just it's a web API. You talk to it, and this is all you talk to. We also have a war simulation running separately, very important. And we have a SQL database. That's where we store the war, so we always keep it. Even if we reboot the war, we still have the data. We keep all the data there. We actually have a lot of player data in there as well, but I'm gonna limit this to only the Galactic War. Like, if it's not Galactic War related, I will not talk about it today, and I'm sorry. We can do that next time, maybe. There's one important aspect. You can see a game client talking to the API. You never talk to the war simulation. The next thing is that the API also doesn't talk to the war simulation. You don't want to do that, because that's a bottleneck, and it's not resilient. Instead, we have a message queue or a message bus, or we used to have that. Now we have something called MS or Leans, which is an actor system, but it kinda does the same job. We are sending tiny packages of data from the API. Whenever a player ends a mission, we grab a tiny little package from the API and say, I want to do 4 damage to a planet. And we send this down the pipe through this Emerald and Cosmos. And I'm gonna go through all these like points in more details later. But just know, we grab a tiny piece and we send it from the API to the simulation. So we bypass this direct connection. But then we update the state, we need to get it back. Here we have something called Redis. It's a caching service. It's a very good caching service. We've never had a single outage on this thing. The API has been down, the war simulation has been down, Orleans has been down, Redis, never been down. It's a fucking champion. So, same thing again. We run all our thing in Microsoft Azure Cloud. We don't host our own services or our own servers, and we can pay as we go. We can scale up as we want. And quite happily here, it's not Arrowhead's credit card at Azure, it's Sony's. Sony pays the bill. Whenever we need anything from Azure, like increase some load, where they need to check, can you afford it? But Sony says, yep, that's fine. And as we're running Kubernetes, for those who don't know, Kubernetes is called like a container orchestrator. We build all of our stuff in a tiny container. We put it up in a giant cloud of computers. We're running 100, maybe 200 of the same server simultaneously. And Kubernetes handles that. It distributes it. If a server goes down, it spins up new ones. Like, it fixes everything. So, the public API is just a web service. We talk HTTP, we talk JSON, we can debug it easily. The war simulation service also runs on a different pod. I'm gonna go into that. It has a web service, but it's not publicly available, and I'm gonna go over what it does later. As I said, we have a Azure SQL or a hosted SQL. We don't want to host it ourselves if we don't have to. This means Microsoft maintains it, and we just pay slightly more for the convenience. Once again, we have a hosted Redis. We pay a bit more. We don't have to do anything about it. Then we have MS Orleans, which I'm going to go into. It's a very interesting system on how you build stuff. But it's a bit much to go now. We store MS Orleans data in something called Cosmos DB, which is a cloud-native document store. And if you've been a game developer, our stack is going to look a bit like out there. If you've done any web development in C# and .NET, you're going to be so familiar with this. We are running by-the-books .NET web development. We're running C#, .NET Core. I still call it .NET, and Microsoft have changed this like back and back again, so I don't know what they call it anymore. We're running ASP.NET for the web stuff. We're hosting it in Kestrel's web server, which is what's included in .NET. As I said, we pack it into containers with Docker, which is a very convenient way to build things and just run it everywhere. You ship a Docker container, you build it, you run it on my machine, on someone else's machine in the cloud. It works. As I said, we store stuff in Azure SQL, we store stuff in Redis, and we store a lot of stuff in Cosmos DB, which is the cloud-native document store. So, the public API, as I said, it's a web API. It's the most common way you communicate. All your apps are probably using web APIs. Most live service games are probably also nowadays using web APIs. We were actually put in contact with Kojima Productions before we got started because Sony had contacts, and they helped us how they set up it for Death Stranding. So we kind of mirrored that, which is you talk HTTP because every client works. There's a client for the PlayStation, there's a client for PC. The Steam Deck works. Like all of your devices can talk HTTP. It works. This server is stateless. It's kind of a pre-requirement if you want to scale horizontally, which means you have one server and then you have the same server running 100 times, 200 times. They can't store anything about you, because if you talk to one server, your next request is unlikely to hit the same one. So you need to be stateless. Every of these ones don't know anything about you. You send them what you know, and that server sends it further somewhere else. This thing handles, as I said, all communication. The game only talks with this. And there's no communication between the game and the war simulation. In order to handle the load, we're using caching. We have to. So we have a Redis cache, that I said, that stores the game state. Every single API host have their own copy of this. It doesn't need to ask anyone else. It knows this. So it's stored in memory, and it sends messages down the path, so it doesn't need to know what it did. It grabs something, packets it, sends it down the pipe to the war simulation later to handle. So my background as a game developer comes in here, because we have the war simulation running in the cloud as well. And even though it doesn't use any framework or engine you know about, it's all custom, it's all C# all the way down. It is very much a game. It runs on a tick basis. Your games might run on a 16 millisecond tick basis, ours runs on 10 seconds. It's good enough. Real time is what you want it to be, right? But if you report a mission every 40 minutes, every 20 minutes, 10 seconds, it's real time. It's good enough. As I said, we are message passing as input. We don't have a gamepad controller. We just have a giant message queues of hundreds of thousands of messages. We parse, we act on it, and we update our internal state, same as any other game. We don't have a screen. We don't display it. Instead, we have the state of the game, outputted as a giant JSON file, probably 4 or 5 megs of JSON. It's enormous, but that's our output. And we send it to the cache, and then we don't care, and we do it all over. So that's our our main loop, basically, for this game, the meta game that runs once. It's also built in Docker, runs the same way. We run it once, very important here. We can't scale this, but there's no need because it's very performant. And most importantly, the load on the war simulation doesn't grow with a player count. The other things do, but the war simulation just ingests messages, work it through. And on a 10-second tick timer, we can actually run a lot of wars. So in our development environment, like our internal dev, we probably have 100, 200 wars running, no problem. QA can spin them up whenever we want to. Any tester can spin them up. Any developer can just have their own custom war. So there's room to spare. It runs in total isolation. Your game client can't talk to it. Also, your game client can't talk to the API you can talk to this. This is both from a performance point of view, but also a security point of view. This war, as I said, is very important, so you don't want anyone to have access to it, to be able to affect it in a way we don't want to. We also have an internal state, like most games, because this server can go down. We need to redeploy it, so we need to store where we were. So we post it in SQL, which is a database that works nicely for this. And we push the state to a Redis cache that it sends to the API host that the players can pull. And we do have a tacked on web service, but I'm gonna come back to this one later. So, just quickly about SQL, because we don't really care. We use the SQL server a lot in the project as a whole, but for the war simulation, we only save the war state. We don't really care. It's ACID compliant. Atomicity means that we can do a single update. We have the full war state, and if anything's wrong with that, we can roll back. We never save a faulty state or a half-baked state or a half-progress state. Like, we can't do that. That's the atomicity part of the ACID compliance. The other parts we care about, but not in the war simulation. And SQL is quite special. It doesn't really scale horizontally, it scales vertically. You can buy a bigger server, you can spend money to get more CPU, more memory, but you can't really scale it horizontally. You can have more servers. And for all of you who know SQL, you know this is not true, but this is a simplification because it takes a lot of time and effort to get it to scale vertically, and we didn't want to do that. So, are you familiar with asynchronous communication? Because it's awesome. There's a programmer I'm listening to who's called Kevlin Henney. He likes to describe them as space-time decouplers. And I think that's a lovely term, because it means you have a server who can come to a conclusion, this is the message, this is what I want to do, and then you toss it on a queue, and someone else, somewhere else, handles it. From your point of view, it's gone, it's fixed, it will handle itself. We went through a few iterations. We were in dev mode. We wrote these damage messages and mission end messages to SQL. It works when your player count is measured in hundreds because it's you and Sony playing the game. It doesn't work with 1 million players, but we knew that and we never intended to keep it. Instead, we went over to a quite famous one, a quite common one that's called RabbitMQ. Main problem is that we didn't use RabbitMQ for anything else. So we introduced a new dependency for a single problem, which is not good from a maintenance point of view. And later, when we started having issues with performance, when we launched the game, we slowly moved over a lot of data, player data, into a system called MS or Leans. And once we learned how it was performant, learned that it could scale, we also deprecated RabbitMQ and moved all the War API to our simulation data over to our Leans instead. So what is MS or Leans? Because I've talked about this a lot. It's an actor system. It is basically a tiny instance of a C# class that runs in a silo cluster somewhere. And when you have multiple people asking for the same grain, they always hit the same instance living hot in memory. You have a low latency. It has data consistency. Famously used by 343 Studios actually. Halo 4 and Halo 5 used this for their backend services. So Microsoft supports it. It works well. I write this. Yeah. So when you're asking for a grain, which is this tiny piece of data, it either lives in memory or you need to read it from persistent storage. If you read it from persistent storage, it's slow, like we're talking 100 milliseconds. If it lives hot in memory, you have sub 10 millisecond access, which for anything over a network, that's incredibly fast. It lives there until unused. Unused is a very configurable term, but generally, when you haven't touched it for 30 minutes, it's gone. It gets saved, and you lose it. A very important thing is that the silo cluster you can host, once again, scale it horizontally. You can have 5 silos, 10 silos, 100 silos. Every grain lives in one of these silos, always. And the key it has makes you find the right one always, so you have a constant lookup speed for it. It handles concurrency. Instead of doing concurrency in SQL, that does it through locks, which is very bothersome. Orleans handles concurrency by locking a single grain, always gets a single thread. You are not allowed to run this thing from multi-threaded. And you're only allowed to talk to it asynchronously. You can't directly ask it for data. You can say, give me data, and it will eventually send you something back. If you're familiar with C#, you send a task, or it returns a task. It tells you, yeah, you will get that data back. But a single threaded entity running on message queues, and it runs them very much first in, first out. So you're never out of sync. If you send 5 messages in, and it stops on the 3rd, the 4th and 5th won't continue and fuck up your state. It will keep them in order. But they are C# classes. So they're not a message queue, because a message queue could only have data. We can actually run logic in this thing, which is very nice, because instead of gathering up 100,000 messages and sending them to the war simulation, we can have the API sending 100,000 messages. But we can start doing aggregation. We can sum it up. So by the end, we might read 100, 200 maybe. So we save a lot of performance by doing logic in this grain. The Orleans have to persist to something. Like, you can run them only in memory if you want to, but that means once it's unused, it's gone, your data is lost. So instead you need to save it somewhere. We chose something called Cosmos DB, and just to make it easy, this is the Wikipedia definition. Azure Cosmos is a globally distributed multi-model database service offered by Microsoft. It's designed to provide high availability, scalability, and low latency to access data for modern applications. What does that mean? It's a cloud-native document store. It has a key, it stores a few K of data in a consistent lookup speed. It runs in the cloud. You pay as you go, you pay for storage, you pay for compute, and you pay for bandwidth. But if you have a problem with scale, you can give Microsoft more money and they give you more performance. It's unstructured data. You can't query it. That's unfortunate. That's one of the trade-offs. SQL is very nice at querying data if you want to do analysis. We don't have that luxury. It stores data in tiny 1K pieces. So if you have a lot of data to store, don't split it up. Figure out another way to do it. And you pay per 1K block. And it doesn't sound like a lot, but when you have 10 million accounts with a few of these, like, it's a lot of data being stored. So we have Redis, and if you've done any modern web development, I think you know what Redis is. Once again, we have the Wikipedia definition, and until this weekend I didn't actually know what Redis stood for, even though I've used it for 10 years. But once again, Redis, Remote Dictionary Service, in-memory storage used as a distributed in-memory key-value database, cache and message broker with optional durability. Because it holds all the data in memory and because of its design, Redis offers low latency reads and writes, making it particularly suitable for use cases that requires a cache. It's a fast hosted cache system. As I said, it's super stable. Redis has never been down once. We have our session management in Redis. We have gigabytes of data. As I said, it's a key value store. Once again, you have a tiny key and you store some value. It stores blobs, but usually people just put some JSON blob in there. We do the same, just our blob is a few megs big, but we have a key. We store the worst data in it. It just works. It says it can be durable. I don't know why they chose to use the word durable, because durable here just means, yeah, you write to disk. So we host our Redis in Azure. We have the hosted version. We give Microsoft money and they host it for us. And we use it for war simulation outputs. Every time the war runs a tick, we create a new entry, with the key being like the war ID and the current time. So we can run multiple simulations and we store all the outputs simultaneously. We store it as JSON, so it's easy to read. And we also have a special key that's just a meta key that basically stores, this is the key to the last update of this war. Now, Redis has something called pipes, and if you're familiar with PubSub solution, this is it. It's a publisher and subscriber relation. We have the war simulation as a publisher. It publishes this meta key. It tells Redis, I have a new update. There exists new war data. We have the API host who subscribes to this. So whenever a new state of the war is published, every single host, if we have 100, 200, they all are informed about it and immediately fetches the new war, and we're live. So the moment we push a war state to the moment we can serve it to the game client, we're talking less than a second. So we're going to talk about a little special thing, because if you've seen our credits, have you noticed that we have this role job description? We have a game master at Arrowhead. He directs the war. He controls this whole galactic war thing that I just told you how we managed. He can do it through personal orders. You can see them here. Controls whatever player is asked. Think of them as assignments. We have major orders. This is a shared thing. The full community are asked to do this together. And we have dispatches. Dispatches are just a little live piece of data we can send to the players whenever we want. Once again, in live, like real time. The Game Master has a very funny thing he can do. He can update the war live. There is a web interface that he can click through, and a few seconds later, we have it in our game client. Every player can see it. Also, he can schedule future changes, which is the preferred way he should work. But he tends not to. So, this is the only picture I could show you, because this is the same view as I showed you, but this is the Game Master view. It's an Angular application, a single page application written in TypeScript. And remember I said that the war simulation does have a tacked on web service. The Game Master tool talks to that. And you have a somewhat of an abstraction or a very distilled view of the game. We have nice tech artists doing the war games in the game. This is mostly me. So, once again, this is the overview. This is how we go from client, talking to the API, sending messages, updating the war, saving the war, pushing the war, getting it out to the API, and it's back to the game client. And this is our core loop of how this works. This is me. This is the guy I've been talking. This is where I post my professional stuff. I've joined Blue Sky quite lately. This is more my hobby stuff, but I'm more active there. And that was the presentation. Question over there? For user data, it was quite painful because when we launched, our main bottleneck was SQL, as expected. So a lot of the stuff we figure out was not useful, you know, like stats tracking. We just pulled it. And we left it disabled for a few weeks until we could rebuild it because we figured it's more important that the game is playable than that your stats are correct. So the answer is quite painful. Yes? Do you mean from what perspective? Yeah. Okay, I understand. Yeah. We're not an MMO. Like, you can't see the other players' avatars. You see them as abstractions. You see them as numbers on a screen, but you never really get to see them as such. Yeah, down there, Matthew? I mean, the fact that we got 800,000 players at launch, if we were aiming for about 100,000, maybe 200,000, we had promised Sony it would scale to 250,000. It did. Unfortunately, we had more players than that. So if we knew that from the start, we would not have gone with SQL because we discussed it a lot. Like, this is not scaling. I'm like, no, we're not going to get the amount of players where it becomes an issue. Yep. Yeah. The game client polls on, I think it's a 5-minute timer. You're max 5 minutes behind the war simulation. But usually you're down on a mission for 20 minutes, and the moment you get back to the ship, you fetch the new status. So up to 5 minutes behind on your client polling. And then you poll a cache, so it's very fast. Down there? Yeah, no, you. They solve very different issues. Orleans is something you build, it's a framework you implement in C Sharp. You need to maintain it. Redis is something you tell Microsoft I want to buy that thing, and we haven't touched it since launch basically. It just works. Yeah. Yeah, I don't want to go into all the details and ruin the mystery, but we did realize we're going to have a fluctuating player numbers, and we didn't know what player numbers we were aiming for, so there is what we call an auto balancer in place, where we're trying to hit a certain amount of damage so the war moves in a predictable speed. So it's more important that people work together than how many they are. But we have a few systems in place to make sure that's not entirely true. We want to keep like the magic factor there. Yeah. No, we have Kafka for Sony's game analytics, but only for that. No, the thing is we had SQL and we needed to replace it with something. So I built a prototype in RabbitMQ. And as you know, nothing is as permanent as a prototype, right? So it lived far too long. I think we replaced it this summer, which is 6 months after launch. So we did it because it served a single function. And if we could remove a dependency and move it into something we needed anyway, we prefer that because of maintenance cost, basically, like development time. And also I remember deploying RabbitMQ was not fun. Yes. Yeah. We refer to have no. We have like we refer to it as three different levels. We have the full game state, like the thing we store in SQL that the game operates on. Then we have a distilled version that we send to Redis as the cache layer, and that's acted upon by the API host. But when you're asking for the state, you get maybe 10% of that, not even that. And it's also very nicely JZipped because it's repeating data. Yes. Yeah. Yes. We generally caught it in the dev environment, but no, you're correct. That has happened. It's not that common because we keep it in mind. So if you do additions only, it tends to work better. But no, we've had a few issues. No big outages that I can remember. Not really. We've had some cheaters affecting the wars in ways we didn't want, but kind of lame compared to what could have happened. Which also means we had live tools to address it. So the moment, if you've been part in any Helldivers community, you will notice that even our community managers and patch notes are written like in world, in universe, which means we had a live system. Usually, we want translations. Sony wants translations to our languages. But if we need to send something out fast, we can just write it up in English, send it out to everyone. So we could address it within 15 minutes. I would not do stats aggregation in SQL due to row locks and connection exhaustion. Like you hit a roof too early. SQL don't like a lot of small people, small messages poking at your database server. They want large updates. And we did the worst of them because we did a lot of like medium-sized updates. So I would still not do stats aggregation in SQL. Or I would pre-work it in Orleans, get an aggregated state and update once. Yes? I'm gonna be honest, I think that 10 seconds is probably too small a number. We could tick it every minute, and I don't think it would change the basic aspect of the game. But I built it, I don't care about the design so much. Yeah. No, we tried a few, like we settled on 10 seconds. It's close to real time enough. Yeah, I think we're well, first of all, for the API, we are doing what's called rolling deploys in Kubernetes, which means that we take a few pods, we roll out a few new ones, and we're never out of pods. There's always an API host serving the clients. For the war, we can remove the war. The war simulation can like go down, be gone for an hour if we want to. The message aggregating, keep going, keep storing those messages, and the latest war session we had is still in the cache. So even if you have no war simulation running, as long as you have something in the cache, every API host still has the latest state and can still send data. So we don't have the real-time thing anymore, but the moment that box is back, everything works as before. We haven't missed a message. We might get some spiky auto balancing, but yeah, it works. We're always playable. I think we're out of questions. So, thank you. Thanks for having me.